Hello viewers, welcome back to another section of our properties of matter tutorial. I have a continuity equation problem which we're going to solve in this video. As water is traveling from a water tower to someone's home. As water is traveling from a water tower to someone's home, the pipes it travels in frequently changes sizes. That is, the pipes are flexible, so it frequently changes sizes. Water is traveling at 5 meters per second in a tube with a diameter of 0.5. So the tube gradually increases in size to a diameter of 1.5 meters and then gradually decreases to a diameter of 1 meters. Neglecting any energy losses due to friction and pressure changes, what is the speed of water when it reaches the tube diameter of 1 meters? So let's see. The water is traveling from a water tower to someone's home. So for this problem, we are interested in the tube. You realize that the tube is frequently changing sizes. That is, it alternates. Since it's flexible, at times it's going to be what? Bulging out. Some it's going to just go inside. So let's see. You're going to have some part of it increasing, then it will decrease, it will increase, then it will increase like this. So something like this. So let's see. So we said the speed of the water initially was traveling at 5 meters per second. Then the tube was 0.5. So 0.5 meters. Then we realized that there was an increase here to 1.5 meters. Then now it was gradually decreased towards 1 meters, assuming there's 1 meters. We have to find the velocity of the water when it reaches here. Remember that the changes in size is affected by pressure differences and which will be due to energy changes. But the question is saying that we should neglect all those parameters. Now, if you have this pipe, remember the flow of water is not changing. It's only the parameters of this pipe which is changing to accommodate. So when it becomes small, the speed has to increase. Then also when it bulges out, the speed is going to decrease. But the rate is actually not changing. So here we are interested in this portion which we want to find the speed here. So let's say this is diameter 1, speed 1, speed 2, then speed 3. We are interested in speed 3. We already have area 3 there, and this is our area 2. So we can take any 2. Now this is what we want. So this is what we take as 1. This is what we want. Then we are going to take this because this is what we have both parameters available. Both parameters available. So now from the continuity equation, you know that A1 V1 should give us A3 V3. What is my A1? My A1, which is my area, is equal to pi r squared, right? So pi r squared, and I need r. What is my r here? 0.5 divided by 2, that is 0.25 meters. So my area 1 becomes 0.25 all squared pi. I have my velocity 1 to be 5 meters per second. V1 is equal to 5 meters per second. When I come here, I have A3 V3. I need A3. So my A3 is equal to pi r squared once again. My pi is going to be what? 0.5 squared. Because I'm having here the diameter increase towards 1 meter. So I'm going to have 0.5 all squared pi, where my V3 is the unknown I'm looking for. So at this point, I further write my expression as A1, that is 0.25 all squared pi, should be equal to, multiplying 5 should be equal to 0.5 all squared pi by V3. So my V3 making the subject is going to give me 0.25 all squared pi by 5 all over 0 0.5 all squared pi. So at this point, you realize that my V3 will simply be equal to, if you have 0.25 all squared over 0.5 all squared, what are you getting? You're getting 1 over 4. 1 over 4. Then you realize that this is what? I'm going to cancel this. I'm going to have 1 over 4 times what? 5. So 1 over 4 times 5 is going to give me 1.25 meters per second. This is the end of the video. Thanks for watching. If you found this helpful, kindly share it to your friends. Don't forget to like and subscribe.